All right, so are there any questions on the homework 1.1 or 1.2 that y'all want to look at or see done?
Which ones do I have to do?
1.2. So we'll look at 7 on 1.1 first, and then we'll start. So we want to write an interval notation. So our 2 points, our 2 kind of boundaries are going to be 3 and 9. And since neither one of them is included, it'll be parentheses. Yeah. Yeah, so whenever you get finished with it, you can either hand it to me or put it on my desk or keyboard, and then I'll organize them at the end of the hour and get them all together. Any other questions? So what we're doing today is applying transformations to the given function. So they're going to give us a function, and we're going to apply the transformations. Now, the first ones we're going to look at are translations. So moving the function up, down, left, or right. So these are the first 2, and the main thing with these are these 2 pieces here, because this is the general form of the transformation, how it's going to be applied to the function. So with horizontal translations, we're going to use the y is equal to f of x minus h. And with vertical translations, we're going to use y is equal to f of x plus k. I'm writing these down so that we can, on the whiteboard, just so we can see them and revert back to them. You have them right there, but they are right there at the top of the page. Now, the horizontal translation left and right is affecting the input value. The number that gets plugged into the function, it's moving it left or right. Correspondingly, and the vertical is either moving the function up or down. It's impacting the output. Any questions on these so far? So the first thing we're going to look at is writing translations of functions. So we're going to look at this here, and we're going to actually work through it, because these are more likely going to make more sense once we do them than just talking about them. So for this first one, we want to write a function g. So we're talking about g of x, whose graph is a translation 3 units down of the graph f, so f of x. So when we talk about moving a function up or down, we're talking about a vertical translation. And the general form of the vertical translation is going to be our f of x plus k, because that's the general form. And with all of these here, when we're applying the transformations, we're going to refer back to these here, because it's going to be easier to think of them in this general form and then applying the parts of the function that we have and the movement to it so that we can see how it works. Now, when we look at this here, our value of k is representing the movement up or down. Now, how far are we moving? 3 units, yes? Will it be positive or negative? Negative, because we're going down, yes? So this here is really minus 3. We could say plus, minus, or plus negative 3, but we know that's just the same as minus 3, yes? Okay. Have we done anything to f of x? Well, no, so it's just the same function that we have. And what is that function? So we're going to replace f of x with plus 1. I like putting things in parentheses, especially if I'm replacing an x or replacing some value or function, just in case. Because if we're subtracting it, that negative will have to apply to everything in that function. So if we have negatives or if we have numbers in front of it, I like putting the parentheses. There's nothing wrong with putting too many parentheses because, again, we can slowly work our way through them and they'll go away. Because if it was subtracting this f of x and we didn't put it there, we'd have a tendency to just apply it to part of it, not the whole thing. So they're better to have than not. Now for this one here, is there anything in front of that first parenthesis? Is there a number? Is there a sign? No. So what can I do with them? I can drop them. Because really the number in front of it is 1. 1 times 2x is just 2x. 1 times 1 is just 1. It's not going to do anything, so essentially we drop them, telling us that g of x is 2x plus 1 minus 3. Do we have any like terms? 1 and 3. Yes, which is? So 2x minus 2. And that's it. So really working with this general form, the g of x equals f of x plus k, it's helping us set up how the transformation is going to affect it, and then we can simplify it. And that's it. Questions on this here? You ready for the next one? Oh, it's just scrolling down the page. And I'm definitely going to redo a lot of these slides because that's way too pixelated. The slides were fine on the old one, but it was a smaller screen proportion. So when it went onto this one and it increased the graphics or the picture size, it made it pixelated. I said this earlier today because unlike CSI Miami, making pictures bigger does not make them clearer. If you've ever watched that show, most of y'all have heard of it. Have y'all ever watched kind of any CSI or kind of criminal investigation where they're doing the murder and trying to solve it? If you could think of every cliche that could possibly be done in that kind of genre of movie or show, this show has it in it to the T, just all of it. Or if you've ever seen people making fun of kind of criminal or those criminal shows, they're most likely making fun of this one. The main character would not do he will do the full line eventually, and he would start the line, put his glasses on and finish, or vice versa, take them off to finish the line. Me and my wife watched it recently. Rewatched it. It's funny because it's just so corny and bad. So, and they would do that all the time. They pour camera on a street corner, way off in the distance. They blow up the image and it's crystal clear. So, we'll get back to this here. Now, for this one here, it says write a function h. So we're just talking about h of x, whose graph is a translation 2 units to the left of the graph of f. So translation left, horizontal left and right. So the general form is our f of x minus h. So the value of h is the movement to the left or right. Now, it tells us that it is moving 2 units. So we know it is going to be 2. But would it be positive or negative? Negative. So we're going to put in negative 2. So unlike yesterday, because yesterday when we were looking at what the transformations were from the parent, that had already been applied, when it's inside those parentheses, it's the opposite of what we think. Here we are applying it, because we're actually plugging in the h value. We don't have to think opposite when we plug it in. So let's see what happens. Do I ever leave it as negative, negative? We change it to what? Yeah, so you can change it there if you want. If you're able to remember that, okay, because I could write over the top of the negative, make it into a plus sign. I'm rewriting it for y'all because it's probably a good thing. So when you go back and look at it, it's not, okay, it just suddenly changed from negative to plus. No, it's negative, then we have the plus. Just as a way for us to remember. Now, from here on, if you want to change it at that point to plus, that's fine. Go for it. Because if you know if you remember the process that we're doing, awesome. If not, we have this here, okay? And if you want to put yourself a note to the side, that works too. So, now our general function was f of x equals 2x plus 1. I'm rewriting it. You don't have to rewrite it, because if you notice on here, the general function's way up the top of the screen. We don't see it anymore. I'm just writing it down here so we can look back to it. Now, any questions on how we got to h of x equals f of x plus 2? We kind of understand how we got here, yes? Our original function was that f of x equals 2x plus 1, yes? Do I have f of x anymore? Now we have what? F of x plus 2, yes? I replaced x with what? X plus 2. So over here in the function, I'm going to be replacing x with what? Yes. Every place there's an x, we're going to replace it with x plus 2. So h of x is going to equal 2 parentheses x plus 2 plus 1. If you remember back to evaluating functions where we would do h of 6, and then we would replace all the x's with 6, this is the exact same thing, but instead of it just being a number, we actually have an expression. We have the x plus 2. Same exact thing. Now all that's left is to, well, simplify this. So we would distribute the 2. 2 times x is, 2 times 2 is, yes. And that's it. Questions on this here? Did y'all think this was going to be more complicated than what it is? Now, we will get to a point where we do more than one of these transformations to a function, where we move it up, because we can move it up and to the left, and stretch it and reflect it. We can do them, all of them, to a function. But even when we do that, what I will suggest and what we'll, when we hit those, is doing like we're doing here. We do each one, as it said, at a time. We do it one at a time, just like we're doing these here. And that's it. So it's not going to get any more complicated than what we're doing here. We'll just take it one step at a time. Because if we do too many of it at once, it does get confusing. Are you ready for this one? Yes? For this one here, we're moving it 5 units up. So, the function g, so g of x is equal to f of x plus k. F of x plus k. Now our value of k in this case is plus 5. We know it's going to be positive because we're moving up, and we have the 5, because that's the amount of units that we're moving. Now again, just like with the first one, we're moving it up or down. We didn't change the function itself, so this is still going to remain. Yes. Yep. We can drop the parentheses because there's nothing in front of it besides 1. Combine like terms, so negative 9 plus 5. Yes. And that's it. A little bit, because with horizontal, we're having to replace x. The x is spot. Yeah. So I'm going to rewrite that down just so we have it on the board to look back to, because your worksheets or your note sheet already has it right there. So you don't have to rewrite that. Now, write a function h, so h of x, whose graph is a translation 1 unit to the right of the graph of f. So horizontal, we're talking about f of x minus h. And our h value is the amount that we move to the left or to the right. So we're moving 1 unit to the right, so it would be positive, yes? So we can just write 1. We don't have to write plus 1, so we just write 1. Which ends up giving us x minus 1. So it's kind of that flipping the sign, that opposite of what we think when we were talking about it yesterday. Well, just like the one before, now we don't have f of x. We have f of x minus 1. So every place that there's an x in the function, we're going to replace it with x minus 1. So what we'll have is 4 parentheses x minus 1 minus 9. Well, now we need to distribute the 4. 4 times x is? 4 times negative 1 is? Minus 9. Combine like terms. So h of x is 4x minus negative 13, or minus 13, yeah. We could say plus negative 13, or just minus 13. But that's it. Questions on this here? How do we feel with these? Do we need to see another one? Or do you guys feel comfortable with this? Still good? Okay. I just want to make sure, because again, I always try to put enough in here that y'all feel comfortable with it. But if we do get to the point that everybody feels good with it, we don't need to see another, we will move on. So I put in enough that we can do extra if we need them, but if we don't need them, we can move on. It's just like I said with the homework, if you can understand it in 3, doing more is not going to make it any clearer. The only time I will do another one is if I know that there's a difference or something that's a little quirky with it, just because of the number or how it's set up. Now what we're looking at next is reflections. And again, just like what we did with translations, we'll have a general form. And these right here are the general forms. Reflection across the x-axis. So we're going to be dealing with y is equal to negative f of x. And a reflection across the y-axis, we're going to be looking at y equals f of negative x. Because a reflection across the y-axis is really changing the input, the numbers that are going into the function. Because all the numbers are kind of the side of f of x, the positive x, are now going to be on the negative side. And all the ones that had a negative input to start with are now going to have a positive because it's flipping it. Because those are the numbers going in. For across the x-axis, well, it's taking all the values that were here and moving them below the x-axis. And all the values that were below the x-axis and moving them above when we reflect it across that x-axis. And really we're talking about the y values, the values that come out of the function, the output. And again, once we start doing these are going to make more sense once we do them, because I think that's the same thing with the horizontal and vertical translations. The definition seemed a little weird, but once we did a few, it's okay, this makes sense. So the first one here, write a function g, so g of x, whose graph is a reflection in the x-axis, so reflection across that x-axis. Yeah, negative f of x. And y in our case is going to be g of x, because f of x, g of x, h of x, q of x, r of x, all of those are just another way to say y. And we use all these different notations to distinguish the two functions. So we can just talk about the function g of x and know which one we're talking about. Well, have we really changed anything about f of x? No, because there's nothing, it's still just f of x. We just have negative in front of it. So what we can do is just replace f of x with its function, which is the absolute value of the quantity x plus 3 in quantity plus 1. So we have this here. Now do we have something in front of those parentheses? We have the negative, yes? So we're going to multiply that through here in a second. So are there any questions on how we got to this point? We just replace f of x with its function, yes? Now we're going to multiply each part of it by that negative. Now, when we multiply an absolute value by a negative, it just stays out front. Because we're saying that we're multiplying that absolute value by negative 1. Yep, so negative 1, or really we're multiplying everything by negative 1. So negative 1 times positive 1 is. And that's it. We don't change it. Because if there was a number we can technically multiply that scale in, we just can't take a negative into it. Because anything that comes out of an absolute value is always positive. So with that negative, what we're saying is whatever the value that's coming out of the absolute value, the number coming out of it is going to be the opposite of it. It's going to be negative. Yep. So the negative stays out front. Questions on this here? Are you ready for the next one? Wait. Yep. I've gotten a little used to having only one problem on each of the slides. So this time we want to write a function h, so h of x, whose graph is a reflection in the y-axis. So this time we're talking about f of negative x of the graph of f. So this time we're replacing x with negative x. So every place that there's an x in this function, we're replacing it with a negative x for this one here. So h of x is equal to the absolute value of negative x plus 3 plus 1. Because again, as we're plugging that negative x in, we're plugging in every place where there's an x. Well, we don't need the parentheses around that negative x because there's nothing in front of it. So really we're saying h of x is equal to this here. We ready for the next part? Yes? I mean, there's no next part. That's the answer. Questions on this here? Okay. Yeah, we just got started a little bit later for some reason. That's fine. We ready to look at this one? Now this one here, they did change it up a little bit. We want to write a function h. All the ones up to this point, we've done g first, so they decided to change that up a little bit. I am not going to be a stickler about that, to where if the problem on the homework says write a function g of x and you put h of x, or if it says write h of x and you put g of x, I don't care about that part, because that's not really what, I mean, it's what it's asking. It's meaninglessness. It's just a letter. So that's not a big deal. But here we want to write it so that it's a reflection in the x-axis. So we're talking about negative f of x. And now we're just replacing f of x with its function. So absolute value of x minus 5, minus 4. And then again, just like with the one before, we'll distribute that negative through. So negative absolute value of, and negative times negative 4 plus 1. And that's it. Questions on this here? We ready for the next one? Write a function g whose graph is a reflection in the y-axis. So we're saying g of x is equal to f of negative x. Did I skip over one? Okay, good. So, well, what do we need to do? We just need to replace x in the function f of x with negative x. So we'd have absolute value bar, negative x, minus 5, minus 4. And then just drop the parentheses, we don't need them. And that's it. Question on any of this here? So